Welcome to Papaul's Projects. This is the fourth in a sequence of videos on making a gantry crane, VSEQ 004. Thanks for watching. You may recognize this AutoCAD assembly drawing from previous videos we've done. So we're going to zoom in on this part. I've disabled the beam assembly. We have the A-frame here, and you will note that I've also disabled this exterior housing on this anti-rotation lock assembly. The pin, as you can see here, is protruding through this plate that's welded on the top of the A-frame, and you can see it penetrates all the way through this circular plate that's welded to the bottom of the beam. So for right now, what we're going to do is we're going to open this lock assembly, and as I said, I have phantomed out this housing just so you could see the spring. The spring here is a commercially available spring. I picked it up at one of my local industrial suppliers. We'll talk about it a bit later. The pin assembly we've already machined. It's was done on the manual lathe. It's been machined from 01 tool steel. We started with a 1-inch diameter drill rod, and we machined it down to this size. In the next video we're going to talk about how we're going to machine this end. But specifically for today, we want to talk about the nut and putting the thread in the nut. As you can see, we have made this nut from, I think it's 1018 steel. We're measuring from this face across the nut to the other side, and you'll notice over here that it's 1.7 inches in diameter. We also are going to measure the distance, and we're going to do this, and we're measuring the distance across there, 1.510. That's exactly 10 thousandths over the 1.5 inch, and we did that to make sure that we'd have clearance when the nut was threaded on the housing, and that this part of the nut this part right here would not interfere with the housing, and that the nut would fully seat and bottom out on this surface down here. So we've generated this nut in here. We have manually on the manual lathe, let me back up and say that we cut with the saw a length of this nut. We put it in the manual lathe, faced the two surfaces, this surface and this surface, until the thickness was from this surface to this surface was 3/4 of an inch. And on the manual lathe we also drilled this hole right the way through the stock. So we're going to now get set to machine the thread, pocket out the opening, and machine the thread on the manual mill. Or I'm sorry, on the VF2 Haas CNC mill. In order to do that, what we need to do is we need to generate a G-code that's going to be readable by the CNC. So it's a two-step process. The first step is we come here and we generate an IGES file, and we're going to save it as this, as an IGES file. I'd already done it, so we're going to just replace it and overwrite it. This concludes what we need to do in the Autodesk software for this nut. So what I'm going to do is I am going to save this and completely close down Autodesk. And when it closes, we're going to bring up BobCAD version 25. So here we are. We're going to open this one. Get that off the screen. And we're going to go up to the file, and we want to open And what we want to do is we want to open an IGES file. So we say that, and we come down here, and there's the file we're looking for, and we say OK. Okay. Now the solid model has been placed correctly in the BobCAD software, except that what we want to do is we want to have it viewed. This is the plan view, and what's shown is the elevation view. So what we need to do is Utilities, Rotate, and we might as well rotate around the x-axis 90 degrees. We say OK. We come over here, we select the part, and we say OK, and we confirm it, and we cancel. Now we're looking at the part down from the top. What we need to do, the pocket that we're going to have to cut is visible to us. It's pointed right at our cutter in the z-axis. And so what we need to do now is set the top surface as the Z. So we go here and we take Control 2, and this gives us the elevation view. So what we need to do here is go to Utilities, Translate, and we need to move this down 0.75 because we know that that's how thick this nut is. We say that, OK, we say OK, and we confirm it here. Wrong, minus 75. We say OK, and we do that again, and we say cancel. We then go back to the elevation view, and if this was a more complicated 3D part, we'd machine it in 3D. We generate the code to do it in 3D. But this is a relatively simple operation, and for the purpose of what we need to do, we're going to do this as simply as we can. So what we need to do is go to Utilities. We want to extract the edges from the solid, this solid, and we say OK. Then we go and cancel this. We view, and we want to blank the solid, and we say OK. And what we have is a wireframe view of the part. Now, we don't need all of these surfaces for the sake of pocketing this out, cutting the thread, and opening up this little recess. So what I'm going to do is I'm going to turn it into elevation view. I'm going to put select, go here, across here, and I'm going to delete everything that is there. Then I say cancel, and I go back to the elevation view. I do the measure trick just to confirm what I have, and there is my, well, it's 0.755. Autodesk Inventor works in terms of diameters for circle, and BobCAD is in terms of radius. So this 0.755 is actually the radius of a 1.51 diameter circle. So we say OK, we're done there. Now what I also should have done was just to confirm that this entity was in fact on 0, and it is. So its center is at x0, y0, and z0, and the radius. Okay, so we can close this. We need something to, we need a point to generate the thread mill thread. So we're going to select arc center, and we're going to pick this arc, and although you can't see it, there is a point that's been generated right here. So we cancel some of these to close them down. Now what we do need is another arc that we've taken away because it wasn't at the correct Z coordinates. So what we need is a radius, a circle that is 1.444, which is the minor diameter of this thread, but again I've put in the diameter, and I need to divide that by 2 to come up with the radius, and there it is. Now this one was not intended, don't need it, get rid of it. So we can confirm that if we measure the entity, this entity here, 7 points over here, 0.722, that's correct. So cancel. Come up here to the cam tree. We're going to do milling. We've got carbon steel. This is the post processor for the VF2 mill, the one that works on our system. Milling stock, we need to set up the stock wizard, and we say that. And what we're going to do is we're going to make the height 0.75, and we say OK. And when we rotate this, you'll see that. And if we bring up the nut, we do view, unblank the nut, you'll see the nut is there. Okay, so we're going to go back to the view here and we'll open the cam tree, and we're going to blank this stock just so it cleans up what we're doing. We don't have to deal with it. So we're going to want to do a 2-axis. Oh, before we do that, I want to do something for clarity. I want to draw another arc, coordinates on 0, but I want it to be a radius of 0.25. And that's there just to remind us that this hole, a 1/2-inch hole, has already been drilled through the stock. It was, we drilled it on the manual lathe when we were facing it. Okay, we're going to cancel this, and now what we're going to do is we're going to machine setup. We're going to 2-axis mill, and we're going to do some pocketing. I'm going to select the geometry, and we're selecting the ID of the thread. We say OK. We go next. We have a rapid plane 0.1 over the part, 0.1 for the feed plane, and the top of the part is at 0, and we say next. Work offset is G54, and we're not putting this out to a 4th axis, so this is unchecked. We're going to want to use a carbide cutter, so we're going to go to the tool library and pick one. This one here will do fine. We say OK. We want to get rid of the automatic numbering. I know this is going to be in tool position 3. We select this one and we say OK. I don't like the tool setting here. It's not set correctly. So I do this at 490. 1.5, 1.5 thousandths. And the plunge this is reasonable but not important because we're plunging down into a hole that's already been drilled. We go next. We want to pocket out. I'm going to use climb milling, and I like about 40%. I'm going to leave a side allowance of 10 thousandths of an inch. We're going to go multiple steps, and each step going down is going to be 10 thousandths of an inch. We're going to use even depths. I say next. If we do this, you'll see that there's this is 625, and this is supposed to be 50 thousandths of an inch. So you'll see that there's going to be 13 passes. We go next. I want it to plunge down again because there's a 1/2-inch hole in there. There's no stress on the 1/2-inch end mill. We're going to the finishing cutter. We're going to say 0, and when we put a 0 diameter in here, the software ignores this tool. We say compute. 1, 2, 3 passes as it goes around. Okay, so I'm going to blank this toolpath, and you recall I left 10 thousandths, so now what I want to do is I want to do a 2-axis. I want to do a profile. I'm selecting the geometry. It's the same ID that we had before. Nothing's changed here. Still nothing's changed here. It's the same tool. We got to make sure this is at 490, and I'm going to set this at 1.5 again, 1.5 thousandths. Say next. Standard contour, 0 allowance. We're going to go down the whole 625 in one step, and we're going to side mill this. So we say next, and we're going to use a circular pattern, 0.25 of an inch, and we're going to compute it. And what will happen here is that the tool will come in here, come around here, and go around. And if we do this, you'll see that one pass. The red line is the travel down. It comes around, goes around here, comes around, comes back, and goes out. Okay, so we've got that. Cancel that, like that. And again, I'm going to blank this just for clarity. And now we want to actually do 2-axis milling. We want to thread mill this. We say next. We select the geometry. Remember that point I put at the center? We select it. We say OK. Go next. That's all good. That's all good. This is not the right mill. This is the default mill. We're going to go to the tool library and we're going to pick one that is close. So about 5/8 by 18. Let's say we use that one. I know that this is in tool position 4. So we go there. We say OK. I'm going to leave this because this works good, well. We're going to go down to the bottom and come up, and it's inside hole. So you can see this is the image, it's shown as an inside hole. We say next. The tool is the thread is 1.5, that's the major diameter. The thread height is 0.04, oops, back up here, 0.044. The thread pitch is 16 threads per inch, so 1.25. And the depth of the hole of the thread is going to be 620. Give us 5 thousandths for clearance on the bottom. We say next. We're going to do a circular pattern, but I already know that 1/2 inch is too much, so we're going to set this at 2.5. The same here. We say compute, and you'll notice that we have the part coming in, and what I'm going to do is I'm going to show this in isometric view, and you'll see that the part is being cut. It goes down to the bottom around here and comes back up and comes out to this point here, and then retracts the tool. Okay, so that's that one done. So again, we say cancel. We go back to the plan view. I'm going to blank this toolpath, and we're going to do the last process. We're going to do 2-axis milling. We're going to do profiling. Select geometry. We're now going to use this outside geometry, outside diameter, the 1.51 diameter. We say OK. All of this is good, nothing has changed. Same tool, again, 490, 1.5 thousandths of an inch, standard, single, we're going to do multiple steps. We wanted to go down 0.625, and I'm going to put in 35 thousandths of an inch, which I know is too much, but it makes it 31.25. There's two cuts, and we say next. We want to do this in a circular pattern. I know that 0.25 is good for that. We say next, next, and we compute it. And you'll notice that again, the tool comes around here, goes around, and it does two passes. And again, if we look at this in isometric view, you'll see the two passes. This red is the rapid plane, and the feed down to the correct z-axis. And there we are, cancel. And we're going to go back to the elevation. And so now we have all of these guys, these tool paths. And what we'll do is we'll go to the cam, we'll say milling, I'll compute all those again, and I'll say post. And based on this post processor, BobCAD has generated a G-code file that can be used to cut the part. We will now, at this point, we'll transmit this straight text file to the CNC Mill via an antiquated RS-232 port at 19.2 baud. I guess it's okay because the VF2 mill is pretty much an antique as well, but works good, gives me accurate finished parts, so I'm happy. So the next time you see us, we'll be coming up with the mill. I'm going to stop this now and we'll go from there.